Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the very last topic of the types of elements of the modern periodic table. That is, we are starting with the inert gases or the noble gases. Friends, the above three sections have been already discussed and covered in the previous session. Please refer to those videos. Thank you. So let's start with the last session of the types of elements. Friends, what are the noble gases? As you can see here in the modern periodic table, the extreme right group is called the noble gases group, or you can say the 18th group or the zero group at the extreme right of the modern periodic table is the noble gases. Friends, the elements in this group are helium, neon, argon, krypton, xenon, and radon. Friends, what are the noble gases? Noble gases we can define as they are the 18th group in the modern periodic table, and the valence shell of all the noble gases are completely filled. Or we can also say that any of a group of rare gases that includes helium, neon, argon, krypton, xenon, and usually radon that exhibits great stability and extremely low reaction rate, we call them inert gases. Friends, why we call them low reaction rate and why we call them great stability? Okay, for example, I'm having a 8-room hotel. I'm running it very good, and my all 8 rooms are already preoccupied by some tourists. So someday if any tourist or any guest comes into my hotel to lend a room, what will I do? Friends, I would not be able to accommodate that tourist just because all the rooms are already preoccupied by the existing customers. Similarly, noble gases are the stable elements because they have 8 electrons in their outermost shell, as they don't have any other room to gain or lose electron from the outermost shell of the element. That's why they are more stable and have very low reaction rate. That is, they don't take part in the chemical reaction. So friends, let's understand some points about this group, as it is placed in the 18th, or you can say the zero group. All the inert gases have 8 electrons in their outermost shell. Friends, according to the octet rule of the electronic configuration of the element, we say that when any element have 8 electrons in their outermost shell complete, we call them stable, just because they don't have any other room to gain or lose electron from their outermost shells. So they are more stable. Have you ever think about why some elements take part in the chemical reaction? Friends, because some elements have unfilled electrons in the outermost shell. That is, they don't have 8 electrons in the outermost shell. To complete the 8 electrons in the outermost shell, they keep on reacting with other elements to form a compound and to get into the stable state. As these elements have 8 electrons complete according to the octet rule, they don't take part in any chemical reaction. Friends, they are also called inert gases, rare gases, zero group elements, or helium group gases. As once known, rare gases, these 6 elements within 18 group of the modern periodic table are known as noble gases now, as helium, neon, argon, krypton, xenon, and radon are the parts of this group, as the use of word noble stems from the fact that all the 6 are extremely non-reactive with other chemicals, and thus noble above reacting with other elements. So these six were also previously called the inert gases, but that description isn't completely accurate because some of these gases can actually participate in chemical reaction, but it is only possible under very specific circumstances. Friends, if I talk about the physical characteristics of these noble gases, they are colorless, odorless, and tasteless, and also inflammable gases. They have negligible electronegativity and have low boiling and melting point. And these gases are actually gas at the room temperature. And the last, these elements are insoluble in water. Friends, if I now conclude all these characteristics under the shade of physical and chemical, I would say that first physical, that the noble gas share three primary physical characteristics as they are odorless, tasteless, and colorless. Noble gases are also characterized by the fact that they remain in the form of a gas while at the room temperature, although they will be converted into liquid state at certain temperature. As the noble gases are insoluble in water, in addition to that physical characteristics, a number of chemical characteristics remain consistent among all the noble gases. Those are: noble gases are highly non-reactive. First, the outer shell of each noble gas consists of valence electrons that are full. This means that they have little tendency to gain or lose electrons. Yes, according to the octet rule, they are actually stable. Now, if we talk about the melting and boiling point, they are actually very close together, that is, differing by less than 18 degree Fahrenheit or 10 degrees Celsius. As a result, noble gases will only remain in liquid state within a small range of temperatures. Friends, above these characteristics, we know that now they are stable, they are non-reactive. But yes, they are also very useful. According to their characteristics, we use them accordingly. As we use helium, as it has low density and stability, and has led to its use in lighter than air balloons. Neon is also commonly used in the glass tubes, neon signs. Argon also helps us in ordinary light bulbs and also in the welding to provide an inert atmosphere. Krypton and Xenon have application in commercial lighting, and both are used in flashing stroboscopic lights used on airport runways. Friends, radon, which is actually a radioactive element or gas, is used in the medical treatments such as radiotherapy. Friends, these are the characteristics uses of the noble gases. Now let's conclude the overall session of the types of elements at the end. Friends, we know that the modern periodic table is being classified into groups and periods. Groups are the vertical columns and periods are the horizontal rows, where we have 7 periods and 18 groups. Then we characterized our table into types of element. First group, which is called as alkali metals. Then we have second group, alkaline earth metal. Third to 12 we have transition metals. Then we have boron family, carbon family, neon family, nitrogen family, oxygen family. Then we have halogens, and lastly we have noble gases. Friends, when we move from left to right, we move from metals to non-metals. In between we have the transit of metals and non-metals, we call them metalloids. And also below this main table we have the lanthanide series and actinide series, which are now called lanthanoids and actinoids, which are actually inner transition metals. Now friends, if we classify the table into electronic configuration of shells, we classify them into four blocks. That is, first and two groups are the S block element. The transition metals are the D block. We have representative elements, that is S block and P block, which actually the last outermost shell is P block, P subshell, and above all, at the bottom of the table, we have the F block. So we have four blocks, S, D, P, F. Now, the last is your activity. I end up my session. Now it's your time to do an activity. It's just you have to do is please go through all the videos of types of element from representative elements to the inert gases. Next discussion, what we have is we have discussed everything regarding the types of element and the characteristics of the groups. But friends, have we discussed about the position of hydrogen, whether it is metal or non-metal? Where should we position the hydrogen in the table? So the next discussion we shall have is the positioning of hydrogen. Thank you.